Hey, I'm Chris Biscardi, and this is Unbundling the Jamstack Metaframework. So to set some context here, I'm Chris Biscardi. I'm an independent consultant. I usually work with companies that are based in open source projects like Gatsby and Docker. For the purposes of this talk, the most relevant experience is Gatsby, so I'll talk a bit about that. Some of the projects that I've worked on in the past, currently, and I'm going to be working on, include a number of different meta-framework technologies, including Gatsby, Next, etc. In this particular case, there's a project that I worked on that informed Gatsby's GraphQL API called LEO, or Low Earth Orbit. That was a prototype of a GraphQL Jamstack meta-framework. I also built Gatsby MDX, if you're familiar with that, or Gatsby themes as well. And currently, and some of the stuff that we'll go over in this talk is a project that I built called Toast, which is the sort of next generation of Jamstack meta-frameworks. Now, what are we going to talk about today? We'll go over the state of the Jamstack ecosystem as I see it. We'll talk a little bit about why we've come to depend on Webpack so much in every single framework that seems to pop up. We'll talk a little bit about what happens once you get rid of Webpack. And then we'll talk a little bit about like what's next after that. So we've got something today. What could we do in the next 5 years? So talking about the state of the Jamstack ecosystem, we've got frameworks. We've got the tooling those frameworks are built on. We've got the features those frameworks and tooling give us, both as developers and as users. And then we've got some problems with those meta frameworks. So there is a set of currently popular frameworks, right? We've got Gatsby, Next, Nuxt, VitePress, and if you click on the link in the slides, it'll show you a thread of Twitter replies where people tell me what their favorite Jamstack meta framework is. And it spans the gamut from Sapper to Gatsby to Next to some that I've never even heard before. Now, if you're not familiar with these, Gatsby is sort of famous for its GraphQL data mesh or content mesh, as they call it these days, as well as Next, which is pretty famous for its serverless integration and server-side rendering. Now, Nuxt is basically mirrored off Next or modeled off Next, although it is now a separate complete project built on Vue. And VitePress is kind of like a similar thing built in Vue, where you give it some markdown and you get a static site generator out the other end. Now, this is a different way of looking at the currently popular sort of meta frameworks, right? And we have Gatsby and we have Next and we have Nuxt and VitePress, etc. But like the differences between, say, Gatsby and Next, which both use React, are both built on Webpack, are fairly small. They're kind of coming at the same problem from two different perspectives, but they're converging on a very similar point in that future. So we have Webpack everywhere, right? Why? Like, why do we have Webpack everywhere? And it's because of our past as web developers, as well as the features that Webpack has that enable us to build these higher level abstractions on top. Our past is complicated, but I'm going to go over a simple, basic sounds in the background, recording. We're going to go over our past in terms of like, where did we used to, say, include our script tags? How did we used to, say, concatenate our scripts together? What kind of module systems were we using in the past? And the answer is, like I was just saying, goes from script tags through AMD to CommonJS and ESModules in the present, and maybe something else in the future, who knows? We'll cover the rise of NPM, which is fairly important to the CommonJS story and fairly important to the Webpack story as well. And then we'll touch on sharing assets and styles, and sort of the first 2 points maybe lead you, if you already know about the history, in the direction of where we're going with that. So the short version here is that CommonJS won. The slightly longer version is that CommonJS won because Node won, which is why NPM came around. So CommonJS won, and then we got ES 2015 modules, but nobody was ready to take advantage of them because we had all committed to CommonJS. So we said we don't want to use AMD, we don't want to use any alternative module system. We're sort of stuck with CommonJS at this point in history. Tools like Babel, when we get ES 2015 modules, are what we use to, say, convert ES 2015 module syntax into CommonJS syntax, which is what we need to do anything, really. Webpack comes in and is basically the coordination or a coordinator of processes that we need to compile ES modules into a node-compatible module system and then do the inferred module graph on all of that stuff, bundle them together, minify them, and ship them, right? So we've got this tool, and this tool exists basically because we decided on CommonJS and also got a new spec module system that we needed to convert between the two. NPM had a huge hand in why we ended up with CommonJS at all, right? Like, Node comes on the scene, they push the CommonJS format, NPM becomes dominant, and then backend and frontend JS both start getting pushed to NPM, right? And they start getting pushed to NPM as CommonJS modules, right? They're not pushed as ES 2015 modules because we don't know it's there yet, right? So now we've got front-end JavaScript sitting in NPM packages on the registry, and we suddenly realize we need CSS associated with those libraries. We need sprites, we need images, we need the fonts that we're trying to distribute amongst our applications and whatnot. So Webpack has support for importing non-JS files, right? And this really solidified sort of the NPM's hold on the ecosystem in a way. We were starting to use NPM more and more for front-end dependencies. It was already being used for back-end dependencies. And Webpack comes in, along with some other tools at the time, like Browserify, and says, okay, we can take an entry point, we can infer a module graph from that entry point, and even if you're importing files that aren't JavaScript, Webpack will have a way to handle them. So if you've got CSS, we'll give you ways to handle CSS files if you import them at specific places in your JavaScript file. And this gave Webpack a lot of power in the past. It was because before Webpack, we were basically doing gulp, grunt, or brunch, or any of a number of different build tools that were basically like, do this, do that, do this, do that. At the end, concat, at the end, minify, and then be done. But Webpack is so much more powerful than that. So when we talk about Webpack features, or we talk about removing Webpack, actually, we need to talk about what it gives us, because we can just remove it, but if we just remove it without understanding what it does for us, we're going to end up in the same sort of like hole of mistakes that we want to avoid. So the main thing that Webpack does for us is file type based processing. You might know this from the rules syntax and the config, or people talking about loaders. There's another really important thing that Webpack gives us, which is hot module reloading. And then obviously bundling, because that's basically what Webpack does, right? That's its main purpose. It gives us image imports and the ability to use bare imports, which is a word that we'll go over later when we're talking more about ESModules. And it gives us higher level functionality, like Gatsby themes is built on Webpack, and it would be really hard to build it in different ways. So when we talk about file type based processing, what we mean is that we can specify a set of rules that apply a set of loaders to a set of files. To make that concrete, if we have like star.js, so any JavaScript file in our entire project is imported somewhere. We want to run that through Babel, and maybe we want to run it with a bunch of plugins. Any .ts file, we want to run through a TypeScript loader or something like that. We want to type check it as it comes into the module graph and make sure that it does what we want it to do. The same thing with CSS files. We might want to send them through CSS modules. We might want to send them through a Sass loader. And further than that, we get this file type-based processing that opens up a whole suite of processing pipelines. And the way that you can separate what happens from the actual file itself is super powerful, right? So we say that for JavaScript files, we are going to load them with this combination of loaders. And we can chain them for complex use cases. For example, here I have star.png, and that says we're either going to use a URL loader, or if the file is too big, we'll use file loader. Hot module reloading is another really important piece of Webpack, and it comes in the Webpack dev server. And this is a quote directly from the docs. Hot module reloading exchanges, adds, or removes modules while an application is running without a full reload. And this is slightly different in the ESModules world, but the idea is that you make a change and then only that code changes in the browser, as compared to some of the older like live reload stuff where you would make a change and then the whole page would refresh and then you would have to navigate back to wherever you just. Now, the downside to this is we get things like React Hot Loader, which have some trouble maintaining state across sort of module replacements. And this is a semi-solved problem in the ESModule land. The other thing that Webpack gives us in terms of features is higher level functionality. Using a Gatsby theme, all of your default configuration, shared functionality, data sourcing, design is abstracted out of your site and into an installable package. This functionality is built on top of the way that Webpack resolves modules. If you've heard of component shadowing, it's built directly on top of the way that Webpack does lookups and gives back paths for where files should exist on the file system to be bundled into the end result bundle. Now, this is a really high level use case for Webpack's internals. We also get things like Create React App and Gatsby itself out of Webpack, right? This is what we're talking about in terms of why everybody uses Webpack, because the dependency graph system that we get to use is so powerful that everybody can use it to do almost anything they want. So there are some problems with Webpack and Webpack related systems. I'm not necessarily saying that all of the problems are with Webpack here. What I'm saying is that the systems that get built on top of Webpack tend to incur a set of similar problems. So this includes Gatsby Next, insert Metaframework here, right? And builds can tend to get pretty slow, especially if you tack on extra, like additional processing like images, right? Images in the Gatsby world are one of the main contributors to a slow build time. This has given Webpack a reputation for not only being slow, but also complex and hard to debug. Which leads us to the next bullet, complexity. Complexity is related to Webpack internals because the internals and the configuration errors are hard to decipher. Webpack uses a powerful tappable plugin system. And if you read the source code, it's not really clear where things go and why, right? If you're not familiar with this sort of very generic ability to tap into anywhere in the Webpack pipeline, which is very powerful and very useful, you're going to be really confused when you see an error that comes out. And finally, bundling compiled modules leads to difficulty deciphering large bundles, right? Like even if you can get source maps to work, of which there are many different ways to get them to work, it's quite different to debug a Webpack compiled bundle than it is to really debug any like regular JavaScript file. So if we look at the set of like next generation frameworks, and this is a term I'm using fairly loosely, as you'll see when I talk about Sapper. But these are all like non-Webpack ESModule first kind of approaches. There's Sapper, there's VitePress, and there's Toast, which is what I'm going to talk the most in depth about. And an alternative way to look at these frameworks is like this. So before we had all the major meta frameworks that are used today, and they all use Webpack. And if we look at the next generation and then the projects that are springing up, they're all using Rollup. And they're using Rollup for different reasons and different ways. But they're using Rollup because Rollup went ESModules first. So converging on Rollup as the base library for any extra work that needs to be done is a really good idea. Now, Sapper, if you're not familiar with it, is a meta framework built on Svelte. It uses Rollup or Webpack for bundling. So Svelte has its own compiler that runs as a Rollup plugin or as a Webpack plugin. As you can see here, I have Rollup plugin Svelte on the slide. And it's a little bit closer to the metal, which is why it's here, right? Like Sapper uses anchor tags instead of linked components. And while linked components are great, they come with certain drawbacks, right? Like the Gatsby link component doesn't have the ability to differentiate between an absolute link and a relative link. So you're stuck using anchor tags for external links and the link component for internal links. And you have to remember to do that. With Sapper, you don't have to remember to do that because you're using anchor tags anyway. Now, moving on from Sapper, which uses Rollup more for bundling straight up, VitePress is a really exciting new project in the ecosystem. The docs, now with Vite and Vue 3, it is time to rethink what a Vue-powered static site generator can really be. And it really is a large rethink. It doesn't support any of the legacy browsers. It goes ESModules first and expects you to use CSS variables. It's built for Vue, as might be obvious. And it uses Vite under the hood. Vite is a really exciting project that is basically like an ESModules dev server kind of thing. And Vite under the hood uses Rollup, which is why we're seeing Rollup in all of these different packages. VitePress, like I said before, only targets browsers that support native ESModule imports. Now, this is one of the first projects to do this, to take the step and say, we're going to break the ties with CommonJS, and we're going ESModules into the future. We're not going to deal with all the legacy complexity that is inherent with dealing with CommonJS systems, and we're just going straight for modern browsers. Toast is in a similar vein, built on Preact, and it uses Rollup as well. It uses Rollup in a way that we're going to talk about a little bit in the future, or in the future of this presentation, actually. But it uses Rollup as part of Snowpack, as sort of like a backwards compatibility thing. And you can think of Toast as like, what would happen if you built Gatsby without Webpack and without GraphQL? So Toast is ESModules first as well. Now, when we go to talk about tooling, what we have is a bunch of bundlers, Babel, NPM, SassPost, CSS modules, Sharp, et cetera, and so on and so forth. So what do we actually expect from a Jamstack meta framework? And fundamentally, the common thread in Jamstack meta framework is you can fetch your data and you can pre-render HTML files, which is a very wide area to talk about. But when you look at all of the different little features that are sort of in every different meta framework, they're not all that different when you look at their core functionality, right? You need to get your data from somewhere. You need to render some HTML from somewhere. And then usually there's a client-side rehydration, but sometimes there's not. So I left that out. So what do we do if we're going to build a meta framework and we're going to get rid of Webpack, right? We're going to start from scratch. Well, we have to look at what the browser actually supports these days. If we do know More Webpack, we're going to go ESModules, right? This is the future. ESModules are the future. We have to take a look at the ecosystem compatibility that comes out of that. How do we deal with CSS now that we don't have the module graph anymore? How do we deal with images now that we don't have the module graph anymore? And if we go ESModules first, we can see the browser actually supports ESModule imports really well these days if you're targeting modern browsers. If you're targeting IE8, I'm sorry. Good luck. But if you're targeting modern evergreen browsers, we get import. We get dynamic import, both of which just work without any bundling. There are some problems with the way that import in the browser works versus Node versus Deno versus some other environment, right? Bare imports don't work. And bare imports, as I showed earlier on this slide, is import preact from preact, right? That bare import specifier that says preact is an NPM module name. That doesn't work in the browser. We need a URL. So if you look at the second bullet point on import problems, we can either import from React or we can import from a URL like /webmodules/react.js. So you can see that we're importing a specific file and not just the bare specifier React. Now, there is a thing called import maps that will work in the future. So if you're interested in bare specifiers and using them, go check that out. Now, for ecosystem compatibility, we have to think about NPM packages. And Toast, in particular, knows that NPM doesn't have great support for sort of ESM packages. This is why things like pkpackage exist. This is why unpackage has a modules flag on it. So what Snowpack does is it takes the part of turning, say, any NPM third-party dependency that uses CommonJS into a file that you can use and import directly into the browser. If we don't have a module graph like Webpack has, can we import CSS files? Like, what do we do with those? We can, of course, get the Webpack style import functionality back through some clever use of Babel plugins and rewriting our import path. Or we can go back to using like the SAS API, like the CLI, the post CSS CLI. And we can just write our CSS in files and then compile it and then ship it. One of the themes of moving back to the browser like this is that we just get to use the same browser APIs that we've always been used to. We get to use style tags. And for advanced cases like hashing CSS file output names, we can post-process HTML and do other neat tricks. Images are another big functionality that people expect from Metaframeworks, right? Like Gatsby has support for images using the Sharp plugin or any number of other things. Now, after seeing so many Gatsby sites, and I've seen a lot of Gatsby sites, I've come to the conclusion that the build process is 100% not the right place to put image processing. Like, you can do it in a separate process. You can do it somewhere else. You can do it in a separate GitHub action. Do not do it in the same process that bundles and builds your code and renders it. It'll slow you down. It's one of the biggest flogs in the Gatsby ecosystem. Don't do it. Use Cloudinary, use something else. So for example, Toast has a plugin that will go through your MDX or your Markdown and upload images to Cloudinary if they exist. So to finish off here, I'm going to talk a little bit about Toast. I talk about the ecosystem, and it starts to become apparent after everything else that we've said that we need a separate process to handle some of these extra things that we want. So Toast relies on Snowpack's V1 implementation to bundle NPM packages into ESM compatible files that we can import from our application. This output can be checked into CI or cached in CI as well. Or checked into your Git repo or cached in CI as well. Toast also takes advantage of this import map file that I've talked about before to map something like, for example, import React from React to import React from /webmodules/preact/compat. Toast, when it talks about data fetching, well, after third-party bundling in the lifeline of building a Toast site comes data fetching. And Toast basically defers this to the user rather than creating a very opinionated, very complex system like maybe Gatsby has with GraphQL. So what this means is that you get to use your SDKs. You get to use the documentation that those SDKs come with. So if you want to use some CMS, you can go to their SDK, use their documentation to actually fetch your data, fetch however much of it you want, however way you want it. And then Toast speaks JSON, so you just talk JSON with Toast, and it'll render your pages out. And this is true for CMSs as well as a file system. When it comes to pre-rendering, Snowpack only really works on the client side. Or it only really works for client-side code. So we need to adjust our imports to work in Node land. And also all these packages that we're importing that we have to compile into these web module files, they already work in Node. So we don't really need to do anything to them. We just need to require them. This gives way to a major architectural decision of Toast. And it's that pages can be self-contained apps, aka regular HTML pages. So this approach means there's no dissonance between some template file and what a page is. In this example, you can see that we've got first-class support for MDX, for example. We pass the module code into the create page call with the data that we want to render. And this gives us both the server-side rendering, pre-rendering that we want, and also client-side rehydration if we so choose. But it's client-side rehydration that is only a single page, which is why we're passing in a single component here that can import whatever it wants, either dynamically or statically. This approach gives way to not only first-class support for MDX, but also true potential for incremental compilation along the entire pipeline. Each page is only rendered from a single component with a single data file, which means that if anything changes in that data or that component, we get to render just what changed. So if all of this sounds interesting to you and you want to hop into the ESModules First future, you can check out my website, christopherbiscardi.com, which runs on Toast. There's a couple other Toast sites. If you want to hit me up on Twitter, I can give you those links as well. You can see Toast under github.com, christopherbiscardi/Toast. And you can see the code for my own site on christopherbiscardi.com. Thank you.